Hello, my name is Donna, and I am going to talk to you about the algebra of Fibonacci numbers. This is not a lesson per se, this is how I would present a class lesson integrating some of these concepts. So, the title is The Algebra of Fibonacci Numbers, and it spans art, nature, music, all kinds of things, and it's titled From Seashells to Sunflowers and More. So, first of all, I would talk a little bit about who Fibonacci is. He's a mathematician from the Italian Renaissance, and he came out with a famous book, Liber Abaci, in 1201. In that book, he discussed many mathematical topics, but two of the most important ones were going from the Roman numeral system to the Arabic system of numbers that we use today. And he also involved a problem involving rabbits and how they multiply. And today it's known as the Fibonacci sequence, named after him. And we use it quite often in a lot of ways in the financial world with stocks, data storage, medicine, growth patterns, computer science, and a lot of other different ways. So we would start really simply just to identify what the Fibonacci sequence is. And you start with the two numbers of 0 and 1, and you add the two numbers together to get the next number in the sequence. So 0 plus 1 is 1, and then you would add um, the other two, which is 1 and 1 is 2, and then the last two would be 1 and 2 is 3, and 2 and 3 is 5, and so on. So the rule with language or with text is that each number is the sum of the two before it, and then we would talk algebraically about how to create a recursive formula. F of n equals f sub n minus 1 plus f n minus 2. And what that means, because algebra is all about going from words and numbers to a algebraic representation of a sequence or formula. Um, it's also a good time in a lesson to talk about different kinds of sequences, such as arithmetic, geometric, and how those compare to the Fibonacci. For instance, an arithmetic sequence would be 3, 5, 7, 2, and you see that we are adding each time um, the number 2, and then geometric involves multiplication. In the example provided in the slide, we have 2, 6, 18, 54. So the previous number is being multiplied by 3 each time. And those both differ from the Fibonacci sequence because you are adding the two previous numbers in the sequence. Another formula that we might want to go over in a lesson is the Fibonacci Sum Formula. That states that the Fibonacci's numbers can be added up together, and it can then be compared to the n plus 2 Fibonacci number minus 1 to create the same value. So that is good to test in the classroom as well. Um, the concept of phi is really important in the Fibonacci sequence as well. When you compare the numbers of the Fibonacci sequence and you take the greater of the number and create a ratio with it with the next number before it, you create ratios, and as you go on and on with the sequence, they tend to go closer and closer to the ratio of phi, which is 1.618. And that is called the golden ratio. And these ratios are used in art and architecture and nature and other areas to create aesthetically pleasing forms. And then we would talk about also how the algebraic form of phi can also be created from that 1 plus the square root of 5 all over 2, and how that would be derived as well. To go delve even further in the mathematics, you can actually create a formula for a particular Fibonacci number using a certain derivation of phi as well, and that would be something to delve into in an algebra class as well. Fibonacci numbers can be used to create stock predictions as well. They're used now, and that's a very important real world application that students might want to learn further. There are other applications as well in computer science and data storage and even medicine. So those would be areas of exploration in a class as well. In summation, we would talk about Fibonacci as a recursive formula and how it is symbolically derived as a sequence as well as a formula. We would talk in more depth about how Fibonacci numbers and sequences and ratios are connected in algebra and nature, and then it is tried to replicate it in art and even music and other areas as well. From the Fibonacci sequence, we would talk about the importance of the golden ratio and how that is used in formulas, in the actual formula of phi, the ratio, as well as Binet's formula to create a formula for generating a particular number of phi. And one of the challenges that we might have for a project in this class is to talk about how a Fibonacci spiral or sequence or even numbers are found in real life, and research additionally some of the real world projects that we talked about. Again, being in optimization, data structures, risk modeling, technical stock analysis, growth model, medical imaging, and much, much more. The sky's the limit with the Fibonacci numbers. I want to thank you for your time and consideration in how we might use Fibonacci numbers and sequences and formulas in an algebra class. I've taught Fibonacci in both the classroom and online and in enrichment programs, and students often find it very fun. They create their own Fibonacci art, their own Fibonacci spirals, and there's endless research projects to do both in the real world and theoretically. So it's a lot of fun, and I hope you will consider implementing Fibonacci numbers and sequences in an algebra class. Thank you so much for your time. Bye-bye.